Okay, so the sum of these values at the end of every year, that's going to be given to us in a geometric series. For a geometric series, you need the A value, so the initial value is going to be $1,000, right there. We need the R value, so the amount that we multiply by, the common ratio, and that is 1.09. And we need the number of terms. We have 1, 2, 3, 4, 5 terms. So let's plug in all of those into our geometric series formula, remember from last unit. This is 1,000, 1.09 to the exponent 5 minus 1 divided by 1.09 minus 1. And when you plug that into your calculator, you should get $5,984.71. Now, if you notice, I'm going to just rewrite this using words, just this formula right here. This is the, sorry, not monthly, but just whatever the regular payment is. That's the $1,000. Multiply that by 1 plus the interest rate to the exponent of time in years, and then subtract 1, divide that by 1 plus the interest rate minus 1 is going to be just the interest rate. This is going to be 0.09. Okay. Now, if I were to rewrite this using some variables, I would get the formula r bracket 1 plus I to the exponent n minus 1 over I. And there's your future value of an annuity formula. So turn to the next page, and I'm going to show you why it changes just a little bit, again, because of the whole compounding frequency issue. So if you compare this formula that I've given you on the top of page 2 to the formula that I just wrote down at the bottom of page 1, the only difference is the interest rate is divided by the compounding frequency C, and the number of years is multiplied by the compounding frequency C. Okay, again, because more often than not, we don't just deposit money into an account at the end of every year. It might be at the end of every month, for example, at the end of every 2 weeks. Okay, so in this formula, R represents the amount of the regular payment or deposit, if you want to think about it that way, in dollars. Okay, I would be the annual interest rate. C is the compounding frequency, so number of compounding periods per year. N would be the number of years, and A would be the total accumulated amount at the end of the annuity term in dollars. All right, let's look at this question. How much interest did Bob earn from this annuity? Well, you know that he invested $1,000 for 5 years, so that's going to be $5,000 that he invests out of his own pocket. So then the interest earned is going to be A minus RN, R being $1,000, N being the number of payments, so in that case 5,000. So the $5,984.71 minus 5,000. So that means he earned $984.71 in interest. All right, again, because the compounding frequency may be more often than once a year, the amount paid into the annuity, so meaning your own money invested, can be calculated using the formula or using the expression RNC. Okay? And the interest earned can be calculated by subtracting RNC from the total accumulated amount. So you might want to just highlight those formulas. And we'll finish off the example in the next video.